Welcome to Device Onboarding Challenge at Edge. Edge computing is now one of the pillars of the Red Hat strategy for the next 3 years, so probably I don't need to explain that edge computing is in essence to acquire and process data as close as possible to where it was produced and consumed. You probably are also aware that what kind of locations, what kind of environments we are referring to when we are discussing an edge computing solution. We are talking about windmills, oil stations, vehicles, trains, retail stores, factory lines, or even wearable devices. But why this interest in Red Hat and in the industry about edge computing? Edge computing brings several technical benefits that could unlock business value. For example, since we are processing data locally, close to the source of the information, we don't need to send that data to the data center or to the public cloud. So we are reducing the latency and we are saving bandwidth, which makes possible to run, process, and get events in real time at the edge location. Those benefits makes possible to create new services or even a line of business related to processing data at the edge. It also provides better user experience using for those applications at the edge, and also give us richer insights that could be used for data science. And lastly, also it could help to meet the regulatory and compliance requirements because we don't have to move the data out from the edge location. The value is clear, but why? Why now? Why is now when we are seeing this edge computing trend? It's a mix of technical and business factors. From the technical point of view, you can see how the amount of data generated over the last years have been increased exponentially. How we can now put more computing power in small devices, or you can see also the rise of the AI/ML solutions. In regards to business, now the user experience is key, is one of the main focus along with the adaptability and agility. And also you can see how the concerns about the data privacy has been increasing a lot over the last years. That's why people start investing in edge computing solutions, but actually the truth is that they are finding several challenges while moving the edge computing solutions to production. The first challenge is scale. In edge computing deployments, we have a range of 100 or 1,000 of devices that you need to manage from a central point, from a central location. And you need to also bear in mind that you need to manage not only the day two, you need to make it simple also the deployment, the onboarding, because probably you don't have you have a minimal or no IT staff on the edge location. Second challenge is interoperability. And this is important, that we don't have a single vendor that can build the entire edge stack. So our solution will need to talk to a third-party solution in the edge environment. And not only that, we also need to be sure that we can be interoperable with all legacy hardware and protocols that we find at the edge location. Think about, for example, a factory, a line of production in a factory. This is the kind of environment that we find in an edge computing solution. Third challenge is security. In edge locations, we find new threats that we don't have or we don't think too much about in data centers on public cloud. For example, physical security. We don't design with physical security in mind when we are designing an architecture for a data center or public cloud, because we know that there is a physical security in place on those locations. That's not true for edge computing locations, so that's something that we need to bear in mind when we design solutions for edge computing. Today we are going to review how these three challenges could be affecting to one of the key points of the architecture or the design of the edge computing solution, which is device onboarding, so the installation of the devices, the deployment and provisioning. This is the agenda for today. First, we will see edge device onboarding challenges, and then we will be moving to review how the feeder device onboarding specification or the FDO specification could help with those challenges. Third, we will be seeing how FDO and RHEL can be used, or FDO in Red Hat Enterprise Linux. And lastly, I will be presenting several use case ideas or examples where you can use FDO along with RHEL. So let's start with the first point, edge device onboarding challenges. Let's think a little bit about the key attributes that we find in an edge solution. We know that those solutions need to work at scale, as we have seen. We need to automate every step and make the management super simple, even the deployment, since we could have no IT people or specialized people at the edge location. Those architectures need to host low latency applications, need to be able to manage high volume of data in transit, even in environments where we have network disruptions, or even in completely isolated network environments. Interoperability is also another factor that we need to bear in mind. We need to be interoperable with the already running systems at the edge location. Also, another point is security, as we have been discussing previously. Even with those new threats that we find in edge computing locations, like the physical security. And lastly, another typical attribute of an edge computing architecture is that the applications will be running in a small resource footprint devices. Why? Because of the cost. If you compare the cost of a regular device, put it at the scale of the edge computing solution, well, that could make the overall cost huge. So if you reduce the cost of per device, so you get cheaper devices, at least the overall cost could be more affordable for the customers. These are the key attributes that we will be taking into account today: scale, automation, network disruption, interoperability, security, and footprint. Why? Because we will be trying to answer one specific question: how can we onboard edge devices at a scale in a secure way? So let's first define what is device onboarding. Device onboarding is the act of including a new device with the specific configuration needed to be integrated in with the rest of running systems. So it's a mix of device provisioning plus the first boot configuration. Let's review the traditional onboarding steps. Step 1. You send the device along with the person who knows how to deploy and configure the device, let's call it the specialist, to the edge location. Next, step 2, that specialist cables and configures the passwords, the certificates, everything that needs to be ready to make the device integrated with the environment. And then third step is that the specialist finish the device configuration and also installs the applications that needs to be running on top of the device. Okay, fine. We have this device installed in this location, but we could have more locations. And we are talking about edge computing. It's not a couple of locations. Probably what we have, maybe we have hundreds of locations. So that's why we have a problem. This process is super slow and super expensive because the specialist needs to move to the next place to start over and over again with step 2. How we can make this process more suitable for edge computing use cases? Well, the actual problem, the actual limitation here, which is what is making it slow and expensive, is moving around the specialist. So let's try to remove it from the equation. With this hand-off approach, what we are doing is we are preparing the device before shipping it to the edge location. So we install and we configure everything, probably by a specialist, in the device, and create some kind of image of the device at this manufacturing location, though we call it. Then, as step 2, we ship the devices to the edge locations. We can do it in parallel, so we don't have to wait anymore to the specialist to be moving around from one location to another. So we send them all in parallel, and then when the device arrives to the edge location, anyone, so someone that has not to need to have any special knowledge, any technical knowledge about the device, could cable it, connect it, and just boot it up, and that's it. He does not need to do anything else. It's just connecting the device and powering it on. Then, as third step, the device starts to running the auto configuration and all the automations that we configure in step 1. So it auto installs and auto configures itself. This seems to be a good option, a good onboarding process, but actually it has a couple of issues. The first one is that we are including a risk. Why? Because we are including the passwords, certificates, so the secrets at the manufacturing site. So when we prepare the device, you just need to think about what could happen if someone have access to this device, or even steal it while shipping it to the location, or even at the edge location, someone that could have access to the device. He could use that information to access the enterprise network, or having access to default passwords. So that's a risk. And there is another issue, is that we could be adding some kind of complexity if we think that we need to prepare devices for different use cases or different edge locations. Why? Because we could end up having not just templates, but a single image per device. So if we have 100 devices, probably we have 100 different images, because we need to change the passwords, the IP configuration, the applications on top of the device. So that could make it complex to maintain this kind of solution. So let's try to improve a little bit this hands-off onboarding process. What we can do is preparing the devices, but without including the secrets in step 1. We could include there some pre-installed scripts. We can pre-install the operating system. We can pre-install client software that runs the automation in later steps. And we can also, for example, give this device an identity. We can identify this device with a hash or with something like this. Then, as a step 2, then again we ship the device. Anyone connects the device, power it on, that's all. And then the difference is in step 3. The device uses that identity that we provide in step 1 and use it to authenticate into a server, create a secure channel, and then download the actual secrets, configuration, automations, everything that is needed for that specific device. If we follow these steps, we remove the risk, because we didn't include the secrets at the step 1. We are doing at the step 3 while we are already encrypting the disk, for example. And we are removing the complexity, because at the step 1 we can prepare templates, just the same template for every single device, and the only difference is the identity of that device. And we use that identity in a later step, so that's what we call later binding. We use that identity to configure one password or another, one configuration or another, one application or another. So we are customizing at step 3, not at step 1. And so we remove that complexity of managing a lot of device images. This secure hands-off onboarding process idea is the base of the FDO device onboarding specification that we are going to cover today. So let's move on and see what is actually FIDO device onboarding specification. FIDO is an alliance focused on providing open and free authentication standards to help reduce the reliance on passwords. As you can see here, there are a lot of big logos supporting this alliance. So the FIDO Alliance took an Intel specification and improved it to create the FIDO device onboarding specification, or FDO specification. So what is the FDO specification? The FDO specification tries to solve the problem of late binding that we have been talking about previously. So not fixing the configuration and the secrets at the moment of the device preparation in step 1. It creates an identity and identification for the device that will be used to enroll the system in a later step, which also makes possible that non-technical users can perform the first boot, as we have seen. Finally, it also helps with the chain of ownership. We didn't speak about it, but this preparation phase, the step 1, could be done by a dedicated group of people or even a third party that we can call it manufacturer. Even between this manufacturer and the actual owner, the actual deployment, could be also involved additional third-party providers that can add value to the edge device before the deployment. So FDO helps to track who took part of the device preparation along with who is the final owner of the device. Let's review how FDO works. At the first step, the manufacturer prepares the device with the certificates, which identifies the device, the FDO client, and everything that needs to be ready to perform the automations in a later step. But not only that, it also creates a digital document that is called the ownership voucher that will be used to track the chain of ownership, because it will contain who is the manufacturer, who is the intermediate partners, and who is the final owner of the device. As next step, the manufacturer ships the devices to the customers, to the edge locations, but also uploads the ownership vouchers to several servers that are called rendezvous servers. In those servers, we will be maintaining this ownership voucher where we track the chain of ownership. Then, once we have the device at the edge location, anyone who does not need this specialization or this specific technical knowledge just boots the device. Then the device who already knows the multiple rendezvous servers that it can contact to, it sends the certificate, so the identity, its identity to the rendezvous server, and then the rendezvous server answers with a list of onboarding servers, so a different server that the device could contact to in order to download the secrets and the actual configuration that it needs to configure. So now the device knows the location of the onboarding server that it can contact to. So it opens a TLS channel between the onboarding server and the device. So we have now a secure channel, and use that secure channel to download the secrets and the files that are needed to perform the auto configuration and the onboarding of the actual device. This is the whole process of FDO, the FDO workflow. Let's see how we can use FDO with Red Hat Enterprise Linux. FDO was introduced in RHEL 8.6 and 9 as technology preview. Each FDO component has its own RPM package, so you can deploy the components independently in different locations, making the solution distributed. So, some of you probably know the zero touch provisioning feature, and now probably you are wondering what is the actual relationship between zero touch provisioning and FDO, this FDO specification. While the idea is similar, they are different features. So we have zero touch provisioning feature for Red Hat OpenShift, which is based in a mix of Red Hat pipelines Tecton and the GitOps approach. So we need a Git repository. We need to have OpenShift. We need the container image registry. This is the infrastructure that we need, and this feature is GA, general availability for everyone. In contrast, FIDO device onboarding specification is for Red Hat Enterprise Linux, not OpenShift. It is based, as we have seen, in files and scripts, not any CI/CD. So we just download the files and scripts from a server. And the infrastructure needed is quite different. We have this manufacturing server, the rendezvous server, the owner server, and this FDO client component that we include into the device. A difference is also that we included FDO in these releases as technology preview, so we have to wait a little bit to have it GA. Okay, so how can we use FDO today? We need to deploy the different FDO servers, inject the FDO client into the device, and launch the manufacturing process that includes the identity into the device and put everything on the device ready to be used. Today, the FDO servers must be installed with these RPMs that we have seen on top of RHEL systems, but in the future we will probably be supporting on having some of the FDO services running on top of our managed cloud services in console.redhat.com. But what about the FDO client and the manufacturing process? Well, for edge computing use cases, you probably should be using RHEL for Edge, the RHEL for Edge flavor, which is a different way of distributing RHEL. So if you want to know more about RHEL for Edge flavor, check the slide deck that I included at the bottom of this slide. So in order to use RHEL for Edge, you need to create an image. And the good news is that while you create this RHEL for Edge image, the FDO client is automatically included in that image. So you don't need to do anything else. You create the image and you have the FDO ready in your image. And also, during this image creation process, you could specify that you want to use FDO. And in that case, you starts automatically this manufacturing process that it's also need to use FDO. So if you use RHEL for Edge and you create the image, you are including the FDO client, and you could potentially start this manufacturing process automatically as a whole, as a same process, everything, image plus manufacturing process, which is really, really good. So let's move on to the last point. It's use case ideas. Here I will be presenting 3 use case examples where you can use FDO. Let's start with the first one. This customer is looking for an edge solution, but he doesn't want to prepare his own devices. He is looking for a ready-to-use solution supported by someone else, by some of his partners. So we could propose that an integrator or any other partner configures the solution and provisions the devices. But remember that in the edge computing solutions, we need to take into account the interoperability. So we need to probably ask the customer to provide to the partner some sensitive data as password, key, certificates of the running systems, which sometimes it's a problem or directly is not allowed. But okay, let's think that sharing this sensitive data is not a problem. for the customer. Now you need to start thinking about the cost of such a service, where the partner needs to send people to install the device around all the customer location, etc., etc. So we can propose a more secure and cost-effective solution with FDO. The integrator could prepare the devices with no customer-sensitive data at their premises, ship the device to the customer premises, and let the customer turn it on. Then the device will contact the FDO onboarding server, which could be managed either by the integrator or the customer if they don't want to share the secrets with the integrator. This model could reduce the cost of providing such a kind of services to the customer, and more even if you think about the scale, where the integrator could have more than just a single customer. So probably the integrator is providing this service for multiple customers. Then you can see the big cost reduction of the overall solution for this partner. Another use case. So this time we have a big customer where there is an organization that manages the procurement and preparation of the devices. They have another organization that provides and supports the application on top of those devices. And they also have the rest of departments and organizations who will be consuming the overall solution. This customer probably found in the past problems related to the amount of effort needed to maintain different solutions based on the department and based on who is consuming and the devices that they are using, along with problems splitting responsibilities between the organization preparing the devices and the organization maintaining the software on top of those devices, since they need to share information and stay well aligned all the time to maintain the interoperability with the rest of the solution. So if you take a look to this diagram, you will see how FDO can help this customer. With FDO, we can split the responsibility between the different organizations. We can remove existing interdependencies between them, between the organization taking care of the device, the one owning the solution on top of them, and of course the rest of the organization consuming the result, the final solution. Let's move to the last example. In this case, we have a partner. This partner develops software that helps customers with their edge computing use cases, and they want to sell the device with their application already built in. Currently, they are struggling because they don't have an easy way to maintain the chain of ownership of the device unless they directly acquire the device from a third party, install their software, and resell it to the customers, which also makes necessary for them to own the entire device supportability, at least from the customer point of view. FDO could help here too. Although today is not possible yet with the current implementation state in RHEL, FDO specifies a way to introduce additional partners between the manufacturer who prepares the device on the first stage and the owner or the consumer of the device. FDO keeps and maintains the chain of ownership thanks to this ownership voucher that is created along with the device preparation, as we have seen during this presentation. Well, and that's all. We have introduced the challenge associated with device onboarding in edge computing solutions. We presented at a high level what is the FDO specification and how it works. We review how we can use FDO with RHEL, and we gave some example use cases where FDO could apply. I want to add this because I want you to remember that FDO is just a RHEL feature, but the Red Hat approach to edge computing is much more than a set of features. It's true that we have platforms such as RHEL, OpenShift, or even OpenStack that can help to cover our customers' edge use cases thanks to certain features and supported architecture designs. But along with presenting our technical capabilities to the customers, Also, always remember to stress the open source message, because that's something that is starting to resonate more and more in many verticals, such as manufacturing or automotive, which is a great advantage for us. It's also important that we don't forget that when you are talking about edge computing solutions, multiple players will be involved, as you have seen in the previous examples. And that's something that Red Hat always had in our roadmap. We had a great partnership approach as a company. We have different partnerships with different vendors and integrators, which is something that our customers will really appreciate it if we know how to explain it to them. And that's all that I want to say with you. Thank you very much for watching.